the microprocessor chip. Okay, and actually the power you can connect through the USB. Right? This is the USB cable, right? Your PC, so you can get the power for this board, or you can use the power port here. Right? This is the power port. You can connect to a battery. Right? Okay, and okay, the rest I will discuss later. And you also have this breadboard, right? Yeah, this one I think you saw it before, right? So the breadboard here, the first two rows are reserved for the power, right? Okay. Usually the red color we say is a plus, right? It's higher voltage, right? And blue color here is minus, which usually we reserve as a lower voltage, ground or whatever, right? So the whole row here are connected actually. Right? That means, let's say you have a wire. Right? So you have a wire. You plug in the wire, right? This one. Okay. If this wire connect to the breadboard. So this is the Arduino board, and this is the breadboard, right? So Arduino board, there is a port here, which is the we call it high voltage, right? VDD board, VDD pin here. And let me see which one. So this is the okay. So this is the 3.3 volt pin, right? So if you connect to the breadboard here, right, the first row, that means the whole row here has the potential, has the voltage 3.3 volt, right? So when you want to use here, you just plug in another wire, right, and plug to any point, right? So you can get the voltage, right? Do you get it? Okay. And the second row here, right, you can connect to a ground, right? So again, I get a ground pin somewhere here, right? From the Arduino board, right? So this one you will practice in the lab, right? So after you do a connection like this one, right? So the whole row, the second row here will be grounded. Okay, it's ground. Okay, then let's look at this simple component, right? Which is the LED, right? You can see, right? So this is LED. So if you look at LED two pins here, right? You can see actually one leg is a bit longer than the other one, right? You can see LED.
Thank you, that's right.
Okay. So you can see the LED, right? It has two legs, right? One is plus, one is minus. Then you can see one leg is actually slightly longer than the other one. Right? What does it mean? So the longer leg, you need to connect to a high voltage. The shorter leg, you need to connect to a low voltage. Right? You cannot reverse. You know, LED, right? Basically, it's a diode, right? Diode is you have direction, right? Diode, you have the direction, right? So this is diode, right? This is diode, right? So in order to have current in the diode, you need to put a higher voltage here, a lower voltage here, right? So that the current can flow, right? So this is a diode, right? So for LED, basically it's a diode, right? Only when you have a current flow, the LED is going to emit the light, right? So this is a light emission, right? So LED basically is what? It's a light emitting diode, right? LED, right? Light emitting diode. So only when you have a current flow, this diode is going to emit light, right? So in order for this diode to emit light, right, you need to put a higher voltage here, low voltage here. Okay, so that the current can flow. So if you put the other way, right? Let's say you put it this way, right? Plus minus, right? So in this way, we call this diode actually is reverse bias. Reverse bias. So once it's reverse bias, there is no current flow. No current flow, no light. Okay? I think this one you know, did you? Right? Yeah, you learned it before, right? Okay. So that's the simple operation for the diode, right? So in order to light up the LED, right, using the Arduino board, so we have to make a connection, right? Let's say I plug in here, right? Okay, so this is the diode. So I put a longer leg here, right? Shorter leg here, right? So in order to light up the LED, I have to connect the higher voltage here, right? Higher voltage here and the low voltage here. Okay. So for the breadboard, right? For the first two rows here, they are shorted horizontally, right? They are shorted horizontally. But for all these rows here, they are shorted vertically. Right? Don't get confused, right? So the rows here are shorted, right? Here. So if I connect, so this is shorter leg, right? So I need to connect to a ground, right? So in this way. Okay? So that means now this pin, right, is connected to ground, right? Through the wire here, right? Okay? Okay, then the other leg here, right? Okay? This leg, I need to connect to a higher voltage, right? Okay? Higher voltage, if you connect to a VDD, they will light up. They will light up. Okay? But now because I don't have power, right, you don't see the light. I can show you actually. So if you do a connection like this one, right? The LED will light up. Okay, so now you see, I connect my power, right? Now you don't see, right? Okay, so just now actually you will see light coming a little bit. Probably I need to use the other side. Anyway. Okay, so once you connect to a VDD here, right, this LED is supposed to light up, okay? Because now you have current flow. Okay? But that's not the point we want to use Arduino, right? The reason we want to use Arduino, basically we want to control. We want to do some control. So we don't want to fix the voltage, right, to the both pin, right? So the LED is always light up. Right? This is not the purpose. The purpose we want to use Arduino is we want to do some control, right? We want to turn on, turn off, whatever, right? So this one we need some kind of programming, right, to do it. Okay. But anyway, this one gives you the basic idea, right? Okay. So what is the board look like and the breadboard, how to do make it. Alright? So you will practice in the lab later. Okay? Okay, so then let me move to the lecture notes part, right? So I will go through the notes first, right? Then I will come back to the Arduino programming later. Okay. Alright, so today we are going to discuss the input and outputs for microcontroller. Right? Okay, so we are going to go through power supplies, right? And what are the digital inputs, what are the digital outputs. Right? So what is the power supply? Power supply, you have some idea, right? So let's say you use your handphone, right? So handphone, where is the power supply? Basically your battery, right? So for this Arduino board, right? We can actually use 3 volt to power up the board. Right? 3 volt basically you just need 2 batteries, right? One AA battery is 1.5 volt, right? So if you connect 2 batteries in series, you will get 3 volts. Okay. And for batteries, right, we have 2 terminals, right? So one terminal is plus, one terminal is minus, right? So plus is high voltage, minus is low voltage, right? Usually we ground it, right? So it's 0 volt. Right? In the olden days, we actually have a positive and negative terminals. So that means one terminal is, let's say, is a plus 3 volts, negative is minus 3 volts. Right? In the olden days, right? But now these days, usually we just use one terminal is 3 volts, the other terminal is 0 volts, which is ground. Oh, okay. All right. And usually, it's a good practice to connect a decoupling capacitor between the VSS and VDD. Yeah? The positive terminal usually we call it VDD, right? That means it's a higher voltage, right? Lower terminal we call VSS, right? Or ground or GND, right? Sometimes you see GND ground. Okay, so usually it's a good practice if you connect a capacitor between the VDD and VSS. This one actually will reduce noise, right? Okay. Okay, so the LED we have discussed briefly just now, right? So what is LED? Right? LED basically is called light emitting diodes. So it's a diode, basically. First is a diode, right? Secondly, it can emit the light, right? Light emitting diode. Okay, so because it's a diode, right? So diode basically is what? It's a PN junction, right? PN. Right? So diode is a one directional device, right? So basically you need to put a plus. So you need to put a higher voltage here, which is we call it anode, and low voltage here, which is called cathode, right? So that the current can flow, the light is emitted. Right? So if you do it reversely, right? So if you put a minus here, plus here, there is no current flow. Or we say the current actually is only the leakage current, which is very small. So in this case, right, no light will be emitted because it's reverse biased. Okay. Okay, so the symbol for the diode, right? So I think you saw it before, right? Basically, it's one triangle, right? One arrow, right? Plus one bar here. Okay, so this is the diode. Right? So for LED, so you see some additional arrow here, right? Right? So that indicates it's a light emitting. Right? So that's the LED. Okay, so we have actually wide variety of LED available in the market. Right? So if in the kit you are going to use, right? Here in the lab, right? You have 3 colors, right? Red, green, and blue. Right? So you can use 3 colors. But of course, there are more colors available. So, for example, like white LED. Okay, so this is the diode you see just now, right? So it has 2 pins, right? It has 2 pins. One leg has a longer. One leg is longer compared to the other, right? So that indicates this one you need to longer leg you need to connect to a higher voltage, and shorter leg you need to connect to a low voltage, right? So don't if you connect reversely, right? So you don't see the light coming out. Okay, you need to be careful with the connection. Okay? Yeah. And the basic LED actually is very cheap. If you buy it in bulk, right, it only costs you like 5 cents. It's very cheap, and you can buy a lot. Okay. Okay, so how to connect LED? So we discussed. We have input and output from the microcontroller, right? So what does it mean is input? Right? Input basically means what? The user, or you need to give something from outside, right? That's input, right? You need to give something from outside to the microcontroller, right? And what is the output from the microcontroller? Basically, the output basically means what? The microcontroller gives out something, right? That's the output, right? So the microcontroller give something out, right? So what is the something, right? It's a voltage, right? What, zero, if it's a digital output, basically it's a 0 or 1, right? Right? It's a 0 or 1. If it's an analog output, what does it mean? Analog output basically is a voltage. It will give out a voltage somewhere. Let's say your VDD is 3 volts, right? So the output voltage will be somewhere between 0 and 3 volts. Right? That's the analog output. Yeah? I'm not sure whether. So digital and analog, right? Digital basically we say we only have 2 values, right? 0 or 1, right? If it's in terms of voltage, right? We only have also 2 values, right? So 0 or 1, right? So what is the meaning of 0 or 1? In terms of voltage, basically is what? It's 0 volt. VDD, if it's a VDD, right? So this is VDD. So if it's 3 volt, then it's 3 volt, right? So that means 1 is corresponding to voltage level 3 volt, right? So this is a digital output. Okay? But if it's an analog output, that means what? If it's analog, so the output can be somewhere in between. The voltage level can be somewhere in between. That's analog. Okay, that's the difference between the digital and analog, right? Analog have more values. And you may ask how many values I can have. It depends on the resolution. So if we say it's a 10-bit output, that means what? You have 10 to the power of 10 levels of outputs. So that means 1024 levels. We divide the 0 to 3 volt into 1024 levels. This one we're going to discuss in more detail later. But that's the difference between the digital and analog. Right? So this one you have to make it clear. Right? But okay. Okay, so how to connect a LED, right? And just now we say, right, if we connect LED to the output pin from the microcontroller, right? So you connect one side to the output pin of the microcontroller, the other side you connect to a ground, right? So this ground is outside, right? So in this case, how to light up? How this LED is can be light up, right? That means if your output is high, if your output is 1, the LED will light up, right? Well, yeah. So if output is 0, the LED is turned off, right? Because if it's 0 here, this side also 0, right? So no current flow, and no light, right? So if you have 3 volts here, higher voltage here, right? So here 3 volts, here 0, right? You'll have current flow, right? Great. So in this case, so basically the LED will illuminate, right, when the logical value of output is high. Right? For this case, we actually call it active high. So in this configuration, we call it active high because the LED will light up when the output is high. The LED is turned off when the output is low. Right? This configuration we call it active high. And what is the reason? What is the purpose you put a resistor here? So resistor here basically we want to limit the current. Right? This one we'll discuss later. Right? So because you see for this LED, right? And previously we have seen we have different color of LED. Sorry, here. So we have typically we have a red, yellow, and green, right? So this LEDs, right? It has a turn-on voltage about 2 volts. Right? And if you have a blue and white LED, right? The turn-on voltage is higher, about 3 volts. So that means if you have 3 volts here, right? So the turn-on voltage here is only 2 volts, right? So if you don't have the resistor here, so if you don't have the resistor here, right? So that means all 3 volts will be applied to this LED, right? So the voltage will be too high. So that's why we need some small resistor here to limit the voltage. So that means if once you have a current flow, right? So it will have some voltage drop across the resistor here, right? So the actual resistor appear across the LED will be smaller, right? In this way, actually, you will limit the voltage across this LED, right? So you can protect the LED. Now this one you will see it in the lab, right? Because in the lab, some of students just forget to put the resistor, right? So you will see actually the LED break. It will break. You will see this LED, right? It's burdened. It happened many times last year. Okay, so we need to connect a resistor right here to protect the LED. But of course, I mean, if you don't connect, right, it depends on the lab. Right? Some students just okay. I mean, yeah. So the LED is still working fine, and for some students the LED is great broken. Okay. So just now we discussed the active high configuration, right? Then you might ask, do we have active low configuration? Yes. The answer is yes. So what does it mean active low? So if you connect a resistor in this way, right? In this configuration, right? Again, one terminal is connected to an output pin here, right? The other terminal, but now you see it's different, right? Now it's connected to a VDD, higher voltage here. And you see the direction, right? Of the LED. You see this one and this one, right? Actually it's reversed, right? So for this one, you see the direction for the triangle, right? It's reversed. So here is high voltage and here is low voltage, right? So now let me ask you, right? When this LED is turned on, when this LED will give off the light, right? So basically, when the output pin is high, is this LED is going to light up? So when it's high, right? So this one VDD, this one VDD, right? So no current flow, right? So no current flow, LED is turned off, right? But if the output pin here is 0, right? If this side is 0, this one VDD, right? So you will have current flowing from VDD to the ground, right? So for this case, means what? When my output here is high, LED is turned off. When the output is low, my LED is turned on. Right? So you can see actually it's reversed from the previous case, right? So for this configuration, we call it active low. Okay. So basically, for this case, right, my output is high, LED is off. Okay, that's the active low configuration, right? Okay. So let me go through the some details, right, for the active high configuration. Okay. And this is the active high configuration, right? So inside the microcontroller here, right? Now we show some details what's going on inside the microcontroller, right? So when the output is low, right? So you can view it as it's like you have a switch inside, right? So when the output is low, basically that means my switch need to connect to ground, right? So you can see my ground here is here, right? So the ground will appear at this output pin here. So my pin here, right? This is my output pin, right? The voltage is 0, right? So the output here is 0, and the other side also 0, right? So no current flow, right? LED is off. Okay. So let's look at the other one, right? Let's say now my switch, right, is connected to VDD, right? So it's a like switch, right? Right? So the first case is the toggle is connecting to a ground, right? So now I change to a VDD, right? So if I connect to a VDD here, that means the voltage at my output pin here is VDD, high voltage, right? The other side is ground, right? So you have a current flow, right? So LED will be like that. Is it clear so far? Yeah, for this case actually, I mean, if you know it before, you will feel it's very simple, right? Okay. So next, let me discuss the resistor. Just now we say, right? The resistor, the purpose of resistor is to protect the diode, right? The LED, right? From the high voltage, right? So a resistor is needed to link up the current, right, through LED. Right? The typical LED just now we discussed red, yellow, or green. Right? These three colors you are going to use in the lab. Right? So it's about 3 milliamp, right, for reasonable brightness. Right? 3 milliamp. So what it means is basically is the brightness of the LED, right, actually depends on the current. Right? So if you have a 3 milliamp current flow, right, so you will see the brightness is reasonable. Right? So if the current is too small, right, so you will see the brightness actually is reduced. Right? So the brightness actually depends on the current, right? So 3 milliamp is a good current. And the voltage, right? Voltage drop is about 2 volts. Right? You just view. Okay, so this is actually a bit different from the normal diode you learned it before, right? What is the voltage drop, right, for the normal diode? Do you still remember? 0.7. Yeah, 0.7, right? So this is the number, right? Last time you learned, right? 0.7. But for LED, right, it's 2 volts. Right? 2 volts is the number you need to remember, right? It's different from the normal diodes, right? 2 volts. But for blue or white LED, the voltage is higher. Okay? And blue and white, actually the white LED, sometimes you might think, what is the problem of why it's so difficult to make a white LED? Actually, it takes the scientists, right, long time to invent the white LED, right? Because you know, what is the white LED? What is the white color? White color basically is it contains all the colors, right? Like all the colors mixed up together is white, right? Right? Because the white color we see in our daily lives, right? It contains all the spectrum of the color, right? Red, yellow, green. Right? So in order to produce the white LED is much more difficult compared to the single color LED, red, yellow, green. Because white you need to have contains all the colors. Okay, that's why it's more difficult to produce white LED. But anyway, the white LED is available now. the market. Again, just give you, and blue LED actually is also, it takes a very long time before it come out in the market, because for blue LED, it's more difficult to find a suitable material to produce. Okay. Anyway, the blue and white LED needs higher voltage, right, compared to red, yellow, and green. Okay. Now, let's suppose we have the supply, right, power supply, which is the 3 volts, right? What value of the resistor we need for this case, right? How can we calculate for this case? Okay, let me use the Okay, so we say we have LED, right? So this one we connect to 3 volts, right? So we say we need to have some resistor, right? And connect to ground, right? Okay, so the question now is how big is this resistor value? So now, just now we have 2 numbers I show you, right? So firstly, I say to have a reasonable brightness, right, we need current, this is current, right, 3 milliamp. Right. And we know the voltage, right, drop across this LED, right, is about 2 volts, right? We use about 2 volts. That means, what is the voltage drop across the resistor? It will be 1, right? So 3 volts, right? This one 2 volts, this one 1 volt, right? Okay, so that means my voltage drop across resistor is 1 volt, right? This equals what? I times R, right? Ohm's law, right? I times R. So 1 volt and the 3 milliamp, right? 3 milliamp, right? 3 milliamp times R, right? Okay, then you will get your resistor value is about 400, right? So you use 1 volt divided by 1 volt, right? Divided by 3 milliamp, right? You will get about 300, 400 ohm, right? About that. Okay, this is a rough estimation. Okay.
G what M? What GM? ME now.
Okay, so next we are going to discuss, right? So just now we say we have output, right? So how much output can drive? How much output can drive? You know, for each output, right? We say we have the voltage is VDD, right? Either 0 or 1, right? For digital output, right? Or 0 or 3 volts. But we never discuss how much current we can provide, right? Just now we say here 0 or 1, right, is voltage, right? But we never discuss how much current, right, it can drive. And for example, if I ask you, right, the output here, right, can I drive a washing machine? Right? So what is the consideration? I need to drive a washing machine. Okay? So to drive a washing machine, for example, right, I need strong current, right? More current. Apparently, if you look at our Arduino board here, right, it's impossible to drive the washing machine because they don't have enough current, right? Okay? So each pin in the Arduino board, right, it can only provide 3 milliamp or 15 milliamp. Right? That's the output from the Arduino board, right? And it can receive the current, right, 6 milliamp or 9 milliamp, right? Depends on the pin, right? And the operating voltage is 3.3 volts. So you can see, if you don't really remember what is the exact value, right? So you will see for the Arduino board, the current range, right, for each pin, right, is about in the range of milliamps, right? A few milliamps. Yeah, that's what you need to realize. Okay. And the total current, total drive current for the whole board, right? It's 130 milliamps. Right? That's the total can provide. Okay. This is a sufficient for LED, right? No problem. LED, just now we say for LED to have reasonable brightness, we only need 3 milliamps, right? So you will see all the pins, right, for this Arduino board have this capability, right? No issue, right? But it's impossible for it to drive a real motor or heater, right, in the washing machine. So in order to drive this washing machine, right, so you need power electronics. Do you learn power electronics before? Yeah, because this note is for is from the UOT side, right? Yeah. So in the second year actually they have this power electronics. For your case, you have already skipped. But anyway, and each of these I/O line, I/O basically means input and output, right? I/O, right? Okay. Each of these input line, I/O line, right, embeds an ODT, right? ODT means it's on-die termination, right? What means on-die termination? That means if you have a driver here, so inside the microcontroller, right, you have one resistor inside, right? So this resistor is about 36 ohms, right? So this is actually all inside here. Right? Okay, why we need a 36 ohm resistor inside the microcontroller? Because you know, for this microcontroller, right, when you're coming out, right, you will connect to a PCB trace, correct? Yeah. So you see this microcontroller here. So this is the microcontroller, right? This one microcontroller, and it has for SAM chip, right? Last time we discussed, it has 144 pins. Right? So this means how to connect to other devices, right? So you have other devices in the board, right? Right? There are some smaller chip and also some of the resistors, etc. Right? So how this microcontroller is connected to other components? Right? Actually, you can see a small wire, right? This is what we call it's called PCB trace. So that's a trace on the board, right? Right? A small wire. Okay? Can you see it? Yeah, it's very small. But anyway, it's a PCB trace. So PCB trace has a resistance about 50 ohms. Okay, this is standard, right? So we need to have some. This one I think I'm not sure whether you go through this kind of course before for the transmission line. Do you learn any transmission line? That's okay because that's the electrical engineering course. Anyway, so you need some kind of impedance matching, right? Impedance matching. What is impedance? Basically, these are the resistance, right? Resistance, right? They also call it impedance, right? So you need to have some impedance matching, right, in order to transmit the power out, right? Okay, in order to transmit the power out. Okay, anyway. Okay, next. Okay, we may let me switch to the board first. Okay, just now we discussed what is output, right? What is output? So how can we program the microcontroller, right, so that we can control the output? Right? So let me show you the some of the program first. Okay, let me open the Arduino IDE. We call it basically it's a programming environment. Can you see? Okay, so this is IDE, right? So if you go to the Arduino website, you can download this package. It's free.